Okay. So we have this list of points, and we start from, oh sorry, this is wrong. Go to list item. Can you follow me? Do you follow me? Okay, if you have problem following me, you have to let me know, okay? Otherwise, I will go on and on until you totally lost. So the default is I, so it get the first point, but we also want the second point. So you zoom in, until you see this plus sign, and you click. 2, yeah, okay, 2 points will be enough. And then we merge these 2 points together to make a list. And then we go to Kangaroo 2 for anchor. Make anchor. Here you have actually an anchor. And then you connect this list of 2 points to the anchor. And then we're going to add it to this ny. We add one more slot of it. And then connect the anchor. Okay, something is wrong because we need to reset it. Okay, now let's see what happened to it. You see, these 2 points are always anchored. And then you try to drag it because the force that you apply to it by this dragging motion overcomes, is larger than the force which is trying to maintain the angle. So somehow it tries to maintain it, but when you drag it far enough, then the angle still forced to change. And if you release your mouse button, then it bounces back. Maybe not back to the original position, but simply it just stays at the space wherever it finds the equilibrium situation of all the force objects. Okay? Okay, so this is the starting position. Okay, let's okay, no problem. Is it okay? Okay. So this is like the warming of the entire situation. Now we are going to move from 1 dimension to 2 dimension. Okay. Okay. Maybe I show you if we switch to the other one, okay, which is the open curve. Okay, and the program still works. Okay, so it is kind of general. It can deal with the open curve and also the closed curve. So if you drag, okay, and you release, then it bounces back. But the first point and the second point is always anchored. So you are not able to move these 2 points. Okay. Okay, so before we go on, I would suggest that you always turn this off so that it won't take out your computational power. Okay, let me I remove the link and let me internalize both of them so that I can remove these 2. And the grasshopper file still keep everything. Okay, maybe before going on for the 2-dimensional membrane, I would like you to practice also one thing. Can we make this a cluster? So that next time we don't need to see all the entire script. Okay, because we are going to do more and more complicated things. How can we simplify this? And we don't have to worry about the detail. We only need to worry about the critical input and output. Okay? And it is a matter of your decision how to dissect this network into 3 parts. Remember, the beginning of this semester, I have introducing the basic idea of generative modeling. You have the variant and the invariant. The invariant will be the process that deal with the problem that you want to do, and the variant are the input of it. Okay, and also the output, but the output will always depending on the input and the process. So this is the same. We have the whole thing, and how can we dissect the whole thing into 3 parts: the input, the process, and the output. Okay, and the way you do it might be quite important, because if you make it very well, then your entire program become very clear and clean. Okay. So here I would say I might want to make it here with the set of line segment as the input. So whatever curve I want to do, first I try to dissect it into segment. Okay, and then the invariant process create the fourth object for me, and then with this output I can connect them to the Kangaroo simulator, Kangaroo solver. Okay, and this might not be that interesting, because this part is the part that you are going to make inside the cluster. Okay, but if we go further backward here, maybe we can cut it so that the curve will become the input of it, and also maybe right now we simply use the default value for number of segment, right? But we can also make it, we extract it, we can make it an input, so that we can use a slider to control it. So we have our first input, the curve. Let me make a copy. And this is another possible input. Okay, and I want to make this anchor as an option, so I will cancel this connection. Okay, and the output will be the length, and also I want to make grab as an option, so I need this output and this output. Okay, so go to parameter, connect to output. Okay, and remove the link between this and the ny, this and the ny. We don't need this text panel. Okay, so now you see this part is isolated from the other part, right? There's no connection between this part and the rest of the program. And we need 2 more input components here. You select all of them and then click cluster. So now it's become cleaner and clear. We have curves and we want to simulate it, so that we connect the curve to the cluster, and also we specify the segment, okay, and then we connect the two force objects to the ny, combine the grab and also the anchor here. Okay, now we need to figure out the anchoring point. Okay, so here we need to do something. Actually, it has been done inside this cluster, but now it is hidden inside this cluster. So we have to redo it outside of it. So we need to divide this curve into the same number of points, and then we connect this to this item. Okay, and I hope that now I can do exactly the same simulation as we have done. Okay, but now you can simply create other curve and then you use this cluster, okay, for the same purpose, and it becomes clearer. Okay, so this is the way you advance yourself from writing a simple program to more and more complicated program. Okay, so this clustering is very important. Okay, now we go on. Okay, imagine now we have a planar mesh. Okay, to simulate the membrane or the lamella, I would suggest that we can use mesh. So if we go to mesh, let me check.